Today it's my honor to introduce to you Mike Horton. Mike is the co-founder, president, and CEO of Crossbow Technology, which is a smart sensor company here in Silicon Valley. And Mike actually started the company, co-founded it, when he was here at Berkeley, where he earned both a BS and an MS in electrical engineering. And also really want to point out that Richard Newton, Dean Newton, was a co-founder as well and served as a board member as well. So Mike, thank you very much for being here. Over to you.
Well, it feels like just yesterday that I was sitting in classes at UC Berkeley. Even though it's been more than a decade, the experience and memories are still very strongly with me. And I will say it's a great honor to get to come back and to talk a little bit about what we do at Crossbow and the story of how Crossbow came about and its evolution out of UC Berkeley into a real leader in the smart sensor industry. So I will walk through kind of an overview of our story, a little bit about where we are today in terms of how the company's emerged. I'll talk at length about the critical, quintessential meeting that took place that really led to the founding of the company and led to my relationship with Richard. I'll talk about our initial market focus in virtual reality and then how that interesting, in a weird and interesting way, led to our core business in UAVs, airplanes, and inertial sensors. And then I'll talk about the experience that we've had reconnecting with UC Berkeley through our efforts in the wireless sensor networking marketplace, and kind of sum up then finally with a bit about the lessons I've learned in the 10-plus years of being an entrepreneur and being a CEO of a high-tech venture capital funded company. The company today, we really consider ourselves a smart sensors company. We were founded in 1995 as I wrapped up my master's in electrical engineering here at Berkeley. We have two today market-leading product lines. One product line is using MEMS sensor technology to build inertial navigation systems. The second product line is a wireless sensor networking product line that has evolved from board-level products into real solutions for logistics and environmental monitoring. The company is headquartered right in the heart of Silicon Valley in San Jose, California on North 1st Street, and has funded itself through a combination of revenue growth and sweat equity, if you will, and also exogenous funding through venture capital. And our lead investors are Cisco Systems, Intel Capital, Morgan Thaler Ventures, and Paladin Capital Group. Paladin, interestingly enough, is a Homeland Security-focused investment firm based out of Washington, D.C. And I would say they're the leading investment firm in the Homeland Security space. The company has a very strong track record of recognition in the sensors marketplace. We have won Best of Sensors Expo Award for 4 years consecutively. We've also been recognized by a lot of the high-tech magazines, such as Technology Review and Red Herring Magazine. We've won interesting awards from our customers, including BP, who awarded us the Helios Award, which is one of the top awards for their technology partners around work we did with wireless sensor networks for condition monitoring. The company also has a really strong history of innovation. In 1998, we came out with the first MEMS-based, silicon MEMS-based inertial navigation system. In 2001, we, in partnership really with UC Berkeley, came out with the first commercial mote that you could buy. Little battery-operated sensor device. We were also the first company to take the MEMS-based technology, micro machine sensors, and actually get it approved for use as primary navigation equipment on manned aircraft. And that is our single largest market today. We sell a lot of our inertial nav systems into aircraft ranging from sort of Cessna 152 aircraft up through business jets, to replace spinning mass gyro systems that have a long track record of being unreliable and in a lot of cases unsafe. There are a lot of documented deaths of pilots due to gyro failure in their aircraft. Undetected gyro failure coupled to an autopilot leading to slow overs, causing catastrophic, going into a spin and actual crashes of aircraft. So we really made a big breakthrough in terms of that technology. And it's been on some very interesting missions. Virgin Atlantic Global Flyer used our equipment as primary navigation equipment in their journey to set the world's endurance record. And one of our interesting customers, controversial customer, Eclipse Aviation, who built the first very light jet, also uses our equipment as primary navigation gear. The company sells its products both directly through OEM sales relationships driven from the company and then through a series of distributors overseas. We have an office in Japan where we have a joint venture with Sumitomo Precision Products, which is actually a MEMS manufacturer and a sales and marketing partner for us in Japan as well. We also have a small office in China, and we have a guy who spends most of his time in Europe. So that supports our distributors worldwide. So I want to turn now to the founding element of the company, and that was really what I call the meeting, and it took place in none other than Corey Hall on the 5th floor. As I recall, at the time, Richard's office was room 520. I think Chris Peaster now sits in that office. I think when Chris came back from UCLA, he wanted a view. That office had a view, so Richard kindly gave him his office. But anyway, in that fine meeting room, I was very interested as a student in figuring out how to get a job, and while I was a student as a summer intern at a startup company. So I went to Richard because he was quoted in an article in EE Times with some perspective on some new software startup companies in Silicon Valley. And I went to him and I said, Richard, I'm really thinking about trying to get an internship. Which of these companies should I apply for a job at? And he had a recommendation. We had a really interesting conversation, and I went off and I got a job at one of the places and had a great time. Came back the next year and decided, well, Richard was very helpful for that. He seemed like a really smart guy. He knows everybody in Silicon Valley. I want to start a company when I graduate, so I should go back and talk to him again. So the second time I went to talk to him, he said to me, well, I've got a very interesting problem I want you to work on. And that problem is, I believe that computer-aided design systems in the future will use virtual reality, that people, when they're designing electronics or designing mechanical things, will actually put on virtual reality headsets and don data gloves and get immersed in this environment and be able to explore the design space in an immersive way. And there's a key problem with building head-mounted display systems and motion-based computer input devices is the tracking. We need some way. The computer needs to know the position and orientation of your hand and your head relative to your body so that when you're in your virtual world, it's got an awareness of your physical location and proximity. And there's no good, scalable, cheap, low-cost, accurate technology for doing this type of tracking and motion-based computing. So he said, I want you to look at that, and I've talked to other students about it, and they haven't been able to get anywhere, but I really think the right way to do this is with MEMS sensors. So you should go down and talk to the BSAT guys and figure out how to do it with MEMS accelerometers. And I said, wow, that sounds interesting, and I picked that up as an undergraduate research project, and up in, that led to really us working together on how to build MEMS-based tracking systems for virtual reality, which, as you'll see here in the next couple of slides, led to the development of Crossbow. So our initial market focus was, in fact, on virtual reality. And 10 years ago, this is all way before motion-based computing, before there was any cell phones with accelerometers or anything came out, we built such a system. And I'll talk a little bit about it. And we had tremendous commercial interest when I was a researcher here at the university working on my master's, finishing up my bachelor's and master's. I got put some stuff up on the very early days of the web, sent out some research, posted some research data, got a lot of interest, and a lot of commercial people wanted to work with us, including there were several startup companies at the time, Forte, Virtual I/O, building headsets for computer gaming. And Microsoft, who built this Sidewinder Freestyle Pro, was interested in working with us. And in fact, Microsoft did work with us and was one of our lead customers in sort of starting up Crossbow. So we had this interest. This research project was a success. We built a prototype of it, and folks like Microsoft and these startups that were doing the virtual reality headsets wanted to to get access to this technology. So Richard and I decided, well, we should start a company. And in August of 1995, we incorporated. We decided that we weren't going to immediately, since we had these kind of customers around that wanted to work with our device, we decided we didn't really think we needed venture capital, and we were going to found the company ourselves, and we did that. We formed it as an S-Corp because we figured it'd be nice to be able to, Richard, I think, primarily figured it'd be nice if there's any losses to be able to take that as a tax write-off, which is the benefit of an S-Corp over a C-Corp. So we founded it as an S-Corp, and each of us put in $25,000 into the venture. I was lucky enough to have recently gotten a little inheritance from a grandfather who passed away, and I had garnished very diligently saved my graduate student researcher wages so that I could also put in $25,000 into the venture. And from that first $50,000 investment, we actually built over $1 million in revenue in the first year. So it was a very quick, firm start to the business, built around, Microsoft was a substantial part of that first $1 million, as well as a couple of other customers who wanted to get access to the technology. And as you will see, some other things came about as well. So the business plan was built all around gaming peripherals. We were going to be the market leader in motion-based computing and gaming peripherals. And we built some IP and a reference design around incorporating tracking technology for virtual reality headsets and sort of computer input devices, things like game controllers. Now, there was a lot of hype about virtual reality. There was a lot of promise, but we were also a little uncertain that this was really going to pan out like everyone thought. The displays weren't very good. The audio quality, the video quality, it was kind of early. I mean, this is 1995 we were talking about. Computers weren't quite as good as they are today. So kind of hedging our bets, we decided we'd run a few ads in Sensors magazines for industrial version of the product as well, because we realized that some of these same problems applied to things like construction equipment and farm tractors, and that would be a good hedge. So we ran some ads in Sensors magazine, which targets kind of industrial, traditional sensor applications as well. Well, what we found out, to make a long story short, we found out very quickly that we were very, very early, and virtual reality didn't go anywhere in 1995. Just to give some perspective on now, motion-based computing is ubiquitous. The Wii has been an absolute runaway hit. All kinds of motion-based computing takes place. Accelerometers are on cell phones to do all kinds of games and to do image rotations and so forth. So the market has happened, but we were over a decade early in terms of mass market for this type of product and capability. Just interesting. Our initial prototype used 6 MEMS accelerometers, and at least in the first incarnation, we had to pay about $300 an axis for a MEMS-based accelerometer. That's how expensive. It was such a new technology, micromachining, that's what it costs. Today, $1 an axis is a high price for a consumer-grade MEMS accelerometer. They're 50 cents or less. And with those 6 MEMS, we built sensors. We built a head-mounted display and a floating joystick. We put together a complete system with architectural CAD software so people could kind of experience how the tracking worked, or if they were into games, you could play Doom with our devices. Now, I was an electrical engineer, so I didn't know much about designing a box for this stuff, and it needed to be packaged up. Actually, we built a full game controller with it as well. We needed help with the mechanics, so we had Paul Wright's class, which I think he still teaches today, designed all the mechanicals, and I had 5 or 6 different headsets with our tracking in it, as well as gaming, sort of the equivalent of the Wiimote. I mean, it was literally the Wiimote that I had 5 or 6 of different mechanical designs. So that is the founding history of the company, and where would we be today if we were just a decade later? That's a very interesting question. We definitely were very early on this concept. Now, one of the corollaries I want to point out is that we did something very smart that benefited us tremendously later in the company's development. We filed some patents at the very beginning of the company's history. And one day, about maybe almost 2 years ago now, these patents all related to motion-based computing and gaming. I got a call from a group that wanted to buy our patents. And we looked at that. We looked at, well, could we, we had very much fundamental IP on that read on the Nintendo Wii. So we thought, well, should we go after them or whatever? Well, it turns out we had a couple people then call us to buy these patents. And to make a long story short, we were able to sell those patents, and it was a very, very rich return for us, given that they were sort of just assets that we weren't using. So sometimes even when your business changes, having core IP turns out to be very useful. Even if your business changes a little bit, you don't use that same IP, we were able to actually benefit tremendously from it without doing any work at all, other than do a little negotiation. We were able to sell those patents for a very handsome profit. So since we were a decade early on the Wii, we were lucky enough to have run those Sensors magazine ads about using our sensor technology for industrial applications. And from that, we got calls. People were calling our phone number, asking us, can we use this device for this? Can we use this device for that? And pretty quickly, a trend emerged that we were getting a lot of calls from aerospace companies. And a lot of calls saying, gee, I've got this old mechanical sensor. Can you replace that mechanical sensor with a MEMS device? Because this MEMS seems like it's smaller, it's a lot lower power, it weighs less, it's more reliable. And we said, yeah, we can do that. And we built our array of standard products to actually, and expanded that from kind of pure motion tracking to actually full inertial measurement and inertial navigation. And that's really what's led to the bulk of Crossbow's development in this marketplace, was those simple sensors ads that we ran. Along the way, it's not all easy. We've had to do a tremendous amount of IP development around drift cancellation. So what is the core IP of our inertial sensors business? It's really taking MEMS technology and making it work almost as good as a ring laser gyro does. And that's a tall order when you consider, even today, a typical MEMS rate sensor has a drift of 10 degrees per second. And inertial math is an integral math. All the processes you're integrating. You're integrating acceleration to velocity to position. You're integrating angular rate to attitude. And so if you have an error and you integrate that error, it becomes a linear projection. If you double integrate, it becomes quadratic, right? So you have to find ways to do drift cancellation. It's very, very important. And we've put a tremendous amount of effort into figuring out how to do that. And you can see we have had a very large gap to close, from 10 degrees per second to 0.1 degree per hour is what we're competing with. And that's given us a rich set of IP to go after and develop. And just to put in some perspective, there as to sort of what we deliver and what a benefit is to that customer in terms of size and cost. If you don't use a MEMS solution for inertial navigation, you have two basic choices of technology: a mechanical gyro or a ring laser gyro. Ring laser gyro systems run over $100,000. They're very large boxes. They weigh over 10 pounds and draw typically 50 watts. So for things like little aircraft, that's just not an option, so they go with mechanical gyros. These are the ones that fail and lead to pilots dying. The problem with them is they have less than 1,000-hour MTBF, and they have hundreds, literally hundreds of moving, they're little Swiss watches, hundreds of moving parts. So MEMS technology for inertial navigation offers tremendous advantages in terms of price point, power, weight, and MTBF. And that's been the heart of our growth in this business, is continuing to innovate around shrinking size and cost and improving the accuracy, closing the accuracy gap with these ring laser gyro systems. And so how do we do that? Well, I'll get into how we do that in a second. So just to kind of step one more time on one of the big markets there for that is, these are actually what these mechanical gyros look like. So for manned aviation, which is our largest market, this is very typically what you would see in the cockpit of aircraft, are these little gyro devices that measure attitude. They're still very ubiquitous, even when sometimes when you get on an older 737, you'll still see these devices. They haven't upgraded to ring laser gyro technology or MEMS technology. So you still even see them on commercial aircraft. You see them ubiquitously in little aircraft. And inside these things is actually a spinning wheel and a bunch of parts And that has really, the industry has made a transformational change to adopt our inertial navigation systems and then couple them with computer-based displays. So you get not only the benefit of the improvement in accuracy and reliability of the gyro technology, it's actually been coupled with innovative displays that represent this on an LCD flat panel along with other sources of navigation and control information. So the pilots got the benefit of improved reliability as well as increased situational awareness. And that marketplace started to take off in about 2003, and Crossbow's very actively participated in its growth. And now you'll see pretty much all general aviation aircraft ship with this type of gear, and retrofits is a huge marketplace right now that's driving our business. So how do we get there? How do we build these things? So instead of throwing fancy sensor technology at it, we basically throw computing power at the problem. We've built an architecture that has a very sophisticated sensor compensation scheme and inertial navigation algorithms which compensate for those drift mechanisms. And we have equipment in our factory that does thermal calibration, temperature compensates all of the individual MEMS sensors, runs them up and down on rate tables, make sure that the vibe characteristics are within capability. We also build magnetometers in our products. We do calibration of those. That's all the sort of physical static calibration. And then we develop very interesting algorithms that run inside of our boxes that do dynamic calibration. So static calibration is taking out fixed error sources. The dynamic calibration takes out errors that build up over time in the use of the product. And we have complete flight control simulation capability that does hardware-in-the-loop capability. Then when we're all done with all that, we go out and validate our products by actually flying against ring laser gyro systems and making sure that we are delivering accuracy that's actually prerequisite. And it all comes, so we had to buy an aircraft for that. So we have our own company plane, which is a lot of fun. And we have about 4 pilots at the company that get to tool around in our aircraft. And all that work kind of sums up in the final product where you go out and you take our product and you compare it to a $100,000 system, and you can take it into a flight test or a drive test or boat test, whatever you want, expose it to all kinds of dynamics, and you can see that one of these two are our product. This one's the $100,000 INS, and you can see that it tracks the motion to typically within a ½ degree RMS accuracy, which is really just astounding that you can take low-cost MEMS sensors, connect them to the right computing, build these algorithms, and take and deliver something that's that good with such basic input. And that's been the real breakthrough for us, is that combination of MEMS and computing power to deliver a solution that's as good as traditional technologies at a fraction of the cost, weight, power, and size. Skip over these. So just in summary, in our inertial sensor business, we've developed from this initial meeting I had with Richard around using MEMS for virtual reality. We've actually become the leading U.S. low-cost MEMS-based AHRS manufacturer with this strong growth focus within aviation and defense markets. And 10 years later, that same core product concept we came out with is still growing. I mean, we've had consistent revenue growth in that business every year for over a decade. And we're still working on more and more things, and I would make a little bit of a pitch here in this particular area of inertial navigation algorithms and design. We are looking for talented engineers, so if you have any interest or have a background in Kalman filters, MEMS sensors, inertial navigation, guidance and control algorithms, autopilot stuff, you should let me know, because we are looking to hire into that team right now. So that is about half of our business. The other interesting half comes right back around to this fine institution of UC Berkeley of wireless sensor networks. So we realized that the inertial sensor marketplace is very interesting. We have a great growth story there, but there's so much more we could do with this combination of MEMS technology, computing power, and we were looking for ways that we could adapt our core competence in signal processing and embedded algorithms to a bigger market. And at the same time we were thinking about that, UC Berkeley was starting a program in smart dust. And I threw up here some of the original motes and one of Chris Piester's original slides on smart dust. And at that time, Chris Piester served on our technical advisory board. He said, Mike, you know, I've got this funding from DARPA. We're going to build these motes. I want to get them out there into the community. And he approached Crossbow to build the hardware for his project, the smart dust project. And we said, great, let's give it a try. And that was the genesis of our efforts in WSN. So we built that hardware, we put it out there into the research community, and pretty quickly a whole little ecosystem and industry was forming all around us. And it was based on, this is actually a David Culler slide that I've used at least 100,000 times. It was all based on this recognition that this type of mote or sensor network device is really the next class of computing that's going to emerge and be important and relevant in the IT world. Kind of following the progression down from mainframes to mini computers to PCs, ever decreasing size of the computing element, ever increasing connectivity of the computing element. The sort of final holy grail here was smart dust, where you would have very low power devices that were tiny, that can be embedded anywhere, that have a sensing capability to interact with the physical world, and a communications capability to get that data out. So that this new class of computing would be one where there are many of these computers per person, and their purpose would be to sort of interact with the world around them and stream information about the physical world around them, therefore forming what is still called the physical internet. And that was it's just a massive opportunity space, and one that we've been really pleased to be a part of. So the first thing, you know, this is all very great. Berkeley did a tremendous service to the community in developing a little operating system in TinyOS. We emerged as a hardware platform supplier for motes that ran TinyOS. Lots of interest from all angles. Great opportunity, but a real challenge for a business to figure out what to go and do in this space. And we found, and there continues to be, tremendous opportunity for wireless sensor networks in building automation, where you're looking at things like replacing thermostats with a wireless sensor device, so you don't have to put all the wiring in to put in thermostats or smoke alarms into a facility. And industrial automation, where our peer company, Chris's company now, Dust Networks, has really done a lot of work in using wireless sensors to replace cabling in factories, to getting information from agriculture to asset management and logistics to physical security, just a whole range of possible applications. So that's great opportunity, but it's also been a real challenge to figure out, well, in each of these things there are a set of requirements, there are a set of needs, there are a set of distribution challenges, a set of sales channels, a value proposition stack that has to work, why customers will adopt wireless sensor networking technology. So this market has gone through a bit of a hype cycle where at first tremendous press coverage of wireless sensor networks, tremendous hype, a lot of companies getting funded, and now has gone through, in 2005 and 2006, a significant shakeout where a lot of ideas have been run to ground and really weren't real tangible ideas, and now starting to emerge again with real solutions. So I want to talk about how we've evolved in that a bit more. So, and doing that, we went out and we talked to lots and lots of customers who bought our hardware and were using it for applications across all of these. And what we really honed in on was it's not about wireless at all. It's really about new data sets. And we honed in on that we don't believe that wire replacement is really what drives people to adopt wireless sensor networks, that it's really collecting data that they couldn't get before. So you have customers in industries where they don't have a lot of IT deployed, they don't have a lot of information about their business, and wireless sensors offers them a way to get a lot of that. And in particular, of these 5 market areas, we focus down into 2 specific ones around asset management and logistics and environmental monitoring. And we narrowed our focus intentionally because we wanted to develop more complete solution stacks to move away from simply a board level mote product and software to an actual complete end user solution. And that's exactly what we've done in 2 categories. In the logistics space, what we deliver is a mobile sensor network device. So this little guy is a cell phone sized device that has in it a set of sensors that can monitor the environmental condition and location of an asset. So it's got a GPS. It actually has a very clever GPS with multiple antennas, and we use a special algorithm to get maximal GPS coverage even indoors. 2 radios, a short-range 802.15.4 traditional wireless sensor radio, so you can get connectivity to this device indoors, and then a cellular radio so that you can get coverage of this device when it's outdoors that works on the GSM network. And we've really made a breakthrough in terms of the battery life, so you can get upwards of a month of data on a single charge. It charges through a traditional USB device. And we sell this into the shipping industry that uses it, and shipping and insurance, that uses this to protect and track assets through the supply chain. And they don't have any of this type of data today, so it's a great breakthrough to them. We sell it as a hardware model. The customers that we sell to then turn around and sell it as a service to their customers, just like in the cell phone industry. So we're sort of the equivalent of the cell phone manufacturer. Our customers are sort of the equivalent of the cell phone service provider. We've developed also, leveraging on top of the cloud computing interface, a very nice web interface for this. So you can see this is one of our employees commuting, who commutes from San Francisco down to our office in San Jose. I can track, I got about 5 of these on key employees, so I know where they are at any time. And I know how fast they drive. And I know where they stop for coffee and so forth. And it's really pretty neat. And our back end can handle literally thousands of devices at a time running around through the supply chain. Not typically on people, typically on things. But for fun, we have a lot of fun testing them as well. The other product that we have put together in the wireless space is a fixed sensor network device. So that device is all about mobility and getting visibility to something that's moving around. We also recognize that in the outdoor world, collecting data is very difficult. Infrastructure is very expensive. It's hard to get power. So we built a complete system for data acquisition for outdoor environments. And what's novel, one of the things that's very novel about this is it's powered entirely off of solar. So it's a wireless mesh device, full mesh. Every device acts as a router. You just put these things into your environment, and they form a network and communicate back to a gateway. But you never have to change the batteries, because there's a solar panel in there that keeps the device charged with literally, you need a couple of hours of sunlight a month in order to keep the system up and running. And again, same architecture on the back end comes into a web-hosted cloud computing service that makes the data available to customers. They can set up alarms and alerts. And our first marketplace for this has, in fact, been agriculture. There's a tremendous need in agriculture to monitor things and to get data, and you have very varied conditions across a crop. And specifically, we found a lot of value points there around irrigation, saving water, frost detection, and then most interestingly is disease monitoring. So we can actually, and we've actually built into our web software, disease models that then compute based off the environmental sensors the likelihood of disease breakouts in certain areas wherever the nodes are located. And we can give a score, what's called an index score. These are all based on models developed by UC Davis, in fact, that tells the farmer when he should be concerned about disease in a certain area of his crop, and then he can go and spray and add chemicals to try to protect that. The device is a very flexible device, has a plug-and-play sensor architecture that allows sensor manufacturers to develop compatible sensors for our platform, and it's received some very good accolades in the industry, and we have a growing distributor network that's helping us broaden the marketplace for this. So very interesting for me to see that we were able to develop one whole business off of one meeting at UC Berkeley, and then come back around in a second pass and work with the researchers here and develop another product line that is going to be a great growth engine for us over the next 10 years. So in all of this development of the company, from its humble beginnings with $50,000 to where it is now, with around 100 employees, I've learned a number of painful lessons, and I wanted to share those with you for your benefit in terms of experiences and your efforts in perhaps starting a company as well. So the first thing that I've learned is that big markets are a must for the venture capital model. You really, if you want to raise venture capital, you want to be addressing a very large market opportunity. And in fact, you really don't want to raise venture capital money unless you are addressing a very large market opportunity. You want to be very honest with yourself and your team about that. Because actually raising venture capital money when you've kind of puffed up a market to be a large market, when it's not really a large market, actually turns out to be a big challenge for both sides of the equation and not really a good fit. You end up, what ends up basically happening is you spend the money anyway, and you don't have the large market, so then you haven't developed, you don't have the revenue base, or the next phase of the funding cycle becomes much more difficult because you've sort of taken this money on this big promise, and that promise isn't really there. So my advice is, if you have a product that addresses a very large market and you have clear visibility to that market, then go for venture capital funding. If instead you have a product that addresses a medium-sized market and you think maybe in the next phase there might be a big market, then find another way to fund the company. Get to the point where you have line of sight and you have a clear demand function, and then raise the venture capital. You'll be a lot less diluted in the process. Your investors will be happier, and you will make, at the end of the day, more money. The second lesson I wanted to share with you is, particularly as a company grows, this gets increasingly important. The incomes, first off, from a business school point of view, I think the most important thing you can take away from business school, I took a bunch of business classes when I was at Cal. The most important one I took was accounting. I mean, accounting is the language of business. You got to know accounting to really be an effective business person. You can't be not understanding the financial statements of a business. You just will not be successful as a business person without being able to read, understand, and interpret financial statements. And certainly, the bigger the company, the more true this is, but the really meaningful statements for a business are the cash flow statement and the balance sheet. The income statement is nice, but GAAP accounting has gotten so complicated with what's revenue, what costs are, it's stock option charges, all these non-cash charges that are on the income statement. They're basically worthless. What you really want to focus on is the business producing cash, and where is the cash going? And the cash flow statement and the balance sheet tell you that. And at the end of the day, all of business's problems revolve around cash. I mean, look at the current total financial meltdown in the world. That's all a balance sheet problem. These guys all had great income statements a year ago. They were all making lots of profits because of the way they were accounting for their revenue, and these loans they were making, they all look great. And now the problem comes down to they don't have liquidity, they don't have cash, their cash flows aren't good. That's where you have breakdowns of business, and that's why you've really got to understand and pay attention to those statements. And of course, the corollary to that is that cash is king. The next big lesson I've learned, particularly in the wireless sensor space, there have been a lot of applications that have come up around the technology that are sort of vitamins. These are things that are nice to do, but aren't must-haves. Vitamins are much harder to sell. You have to be very clever at marketing and very just a little bit lucky in a lot of cases in order to sell vitamins. Whereas painkillers, things that actually solve a real problem where there's a real business pain, are much, much easier to sell, and they're much more resilient in good times and in bad times. So you got to look at your product and really understand, is it a painkiller? Is it something that's going to really take pain away from a customer, or is it a vitamin? Is it something that's nice to have, something that kind of adds fluff to their business, but it's not necessarily core to their business problem? If you're in the vitamin business, you better be damn good at marketing and sales. If you're in the painkiller business, then I think you have an easier go of it. Protect the hell out of it with a lot of IP, and focus on execution. Another important lesson that I've learned in business is, as we have a fairly wide product mix and do a lot of different things and different applications, focus if you know what you're doing, focus is a lot less risky than diversification. So a lot of times it's tempting when you start out with a new idea, you get a lot of different input. Oh, I could do this with it, I could do that with it. There's a market here, there's a market there, here's an idea there. And it's very tempting to say, well, I'm not really sure this is going to work out, so I'll take on this, and I'll take on this, and we'll take on more different things. It turns out that diversification strategy, if you will, turns out to be much more risky than people really realize, because it dilutes your focus and it dilutes your resources and it reduces the probability of actually winning in specific areas. So focusing is a lot less risky, in my opinion, than diversification. And that just puts an emphasis on really knowing what you're doing in the market that you're in, really understanding your technology and staying true to that, and being absolutely as focused as possible in your business plan. And my last lesson that I've learned is really how to be a CEO. So I started the company, and unlike a lot of entrepreneurs, I didn't recruit an outside CEO. I've been the CEO of the company since inception and been through some tremendous times and also some really challenging times. And I've had to learn, really with no training whatsoever, how to be a good CEO. And the first thing that I would say about being a good CEO is you got to keep learning. It's a continuous process. And what I've learned in doing that is that there are two core skill sets you got to have, and they're different skill sets, and they build on each other, but they're very, very hard to do at the same time. And the first skill set revolves around being an operating executive, and the second skill set revolves around being an investor yourself, being a knowledgeable and smart investor. And you got to be able to do both at the same time. So on the operating executive side, you got to do a lot of things very well. You got to promote teamwork within the company. You got to get people who oftentimes have differing opinions to get to the table and to enjoy working with each other and to thrive on challenge and succeeding. You got to do a lot of recruiting. You got to have a very keen sense of quality and a lot of pushback on folks. You got a lot of internal reasons why you want to get things done or call things complete. You got to really maintain a focus and a discipline on quality, and you got to be very good at selling yourself. A lot of the key deals in your business come down. Sales guy gets to a point, but at some point a key customer will want to see the CEO committed, and you've got to be able to convince the customer to sign the deal. Those are all what I call operating executive skills, and they're all breadth, and they're hard work, and they involve a lot of tactical chutzpah to a certain degree. But at the same time, that's not enough to be a CEO. At the same time, as you're doing that, selling focused, selling on products, working with the team, focusing on quality, recruiting people. At the same time you're doing all that, you also have to be a very wise investor, because you are the final decision maker on allocation of capital. What products are we going to invest in? When are we going to invest in those products? How much are we going to invest? How are we going to allocate that precious few dollars we have? Who are we going to hire? How many people are we going to hire? Those skills are the skills of an investor. They require tremendous analytical skills and tremendous independent judgment. So on the one side, you're trying to work with people and be a team player. On the other side, you're having to be very hypercritical of your team, hypercritical of what you're doing, looking at what the marketplace is doing, and ultimately being an investor. So this combination is really, I think, unique to the role of the CEO, and it's a skill that is just unbelievably demanding to be able to balance those two things and do it in a graceful way that keeps both investors, employees, and customers all happy at the same time. It's a daunting task, but one that is also extremely rewarding, and one that is really a great growth, personal growth type of experience to take on. So many are called, few are chosen. It's a challenging role, but it's also a very rewarding role. And that's the hardest lesson I've learned in the business, is how to be a good CEO. And I continue to strive every day to be a better CEO by working on all of these skills, and by working with people who are smarter than I am to give me guidance and to keep the growth path. And with that, I would just close in saying, one of the key people in my business and venture who's helped me learn to be a great CEO is Richard Newton. So it's, again, just a great honor to get to talk at a lecture series named for my great friend who I miss dearly, and has been just a great partner for me in everything that I've done. So thank you.
So some people are early to market, and so they missed the opportunity, but you were still around when the Wii came out. So how did that not happen? You were the best in low cost. It seems like the iPhones and the Wii would have been your dream job. Just repeat the question, please.
Sure. So the question is, how come we didn't participate more in the Wii? Well, I think the answer is our business evolved so much in the aerospace side, we stopped tracking that space altogether and weren't really working on it other than we had latent IP around that covered it. And in fact, because it took so long to develop, a lot of what was unique about what we did, which was the algorithms of how to compute roll and pitch for a basic tracking device, became also commoditized and became more obvious as the devices were out there. So again, it came back to, well, we had fundamental IP on it, but we didn't really have a product play anymore at the level of commoditization that occurred in that 10-year span of time.
Are there other questions now? Otherwise, if you want to talk to Mike after the lecture, we can do that as well. There's one question.
Have there been efforts made to integrate the MEMS computing infrastructures like systems on a chip for like avionics efficiency?
Yeah, I mean, there's a lot of integration that's occurred. There's still some incompatibility with processes, so full system on a chip in a lot of cases isn't totally optimal, but a lot of analog electronics has gotten incorporated onto MEMS. Some MEMS sensors now are digital. It varies on the process. For the aerospace applications that we go after, accuracy is so key. We tend not to want to compromise accuracy by kind of integrating electronics, so it leads to a little bit larger micromachine structures and a little bit more precision in the micromachining as opposed to something like the accelerometer in a Wii where cost is everything. Then system on a chip is a really more appropriate technology.
With the Smart Dust product, with so many different sensors, how big the problem is the large incoming streams of data, and what kind of tools are you using to analyze that data?
The data sets are large, but they're not so large that it takes incredible tools to manage them. What we've leveraged off of recently that's been a huge help for us and for our customers is cloud computing. So previously we built custom data management tools that were PC-based applications that would let customers sort of sort through their data. That turned out to not be so easy for customers to maintain and install, and since the customers are not very IT savvy, the cloud computing model where that data gets pushed up onto the cloud and hosted by a Google or an Amazon, and we just build the GUI interface to sort and present that data has worked extremely well for us. Because we're no longer sort of responsible for the data management that's being hosted, in our case we use Google, being hosted by Google, and our customers can go directly to the web and get to their data, and that data is there 100% of the time. All the replication across all the geographies is all handled for us. So for us, that problem has been one that cloud computing has really helped us solve that problem and get back to really delivering the value that we deliver, which is new sensor data to customers.
All right. So there's going to be, if you guys want to talk to Mike, there's actually going to be a small reception right here afterwards. But Mike, thank you very much. This was excellent.